So in today's session, we will discuss how to find the sum to n terms of a given geometric progression. So let's begin by first stating the geometric progression. Let's say we have our first term denoted by a, the second term will be ar, the third term will be ar squared, and it goes all the way up to the nth term, which is ar. So let's consider the second last term as well, ar raised to the power of n minus 2 and ar raised to the power of n minus 1. So this is a geometric progression. Now the task is to find out the sum of these n number of terms. So that means we want to find out Sn, where Sn will be first term plus the second term plus the third term going all the way up to the second last term, ar raised to the power of n minus 2 plus ar raised to the power of n minus 1. So let's label this as equation number 1. Now we will multiply both sides of equation number 1 with the common ratio r. So that gives us r times Sn, which will be equals to, so a multiplied to r is going to give us ar, then ar multiplied to r is going to give us ar squared going all the way up to, so we have ar raised to the power of n minus 2 but multiplied to r, so this is going to give us ar raised to the power of n minus 1. So let this be equation number 2. Now what we'll do, we'll subtract both of these two equations. So 1 minus 2, this is going to give us Sn minus r times Sn equals to the first term a. So here we'll see that the ar term cancels out, ar squared cancels out. We have ar raised to the power of n minus 2 and ar raised to the power of n minus 1 also getting cancelled out. So I missed out one term here. There will be plus ar raised to the power of n. So ar raised to the power of n, that's obtained by multiplying r with the last term of equation number 1. Right. So that means we are left with only the first term from equation number 1, which is a, and the last term from equation number 2. That means negative ar raised to the power of n. So we can take Sn as the common factor on the left hand side. So we have Sn multiplied to 1 minus r equals to, and we can take a as the common factor on the right hand side. So we have a times 1 minus r raised to the power of n. Now dividing both sides by 1 minus r, so Sn will be equals to a times 1 minus r raised to the power of n divided by 1 minus r. So this is the sum to the nth terms of a given geometric progression. So we can also rewrite this as Sn equals to a times r raised to the power of n minus 1 divided by r minus 1. This can be done if we subtract 1 from equation number 2. Now, there's a reason why we are using two equations. The first one, this particular equation holds true when our r value is less than 1. And this particular sum, we'll be using this formula whenever the r value is greater than 1. For example, let's say the common ratio could be half or negative half or negative 1/3. And in this case, the r value could be 2, negative 3, and so on. Right. So now that we have the formula for finding out the sum up to the n terms of a given geometric progression, let's try this out with the help of few examples. So we have these following problems. In each of them, we need to find out the sum up to the given or to the given terms. So let's begin with number 1. So we have the geometric progression 3, 6, 12, and we need to find out the sum to the 7 term. So let's first note down what we are provided with. So here we have the first term. So our first term will be 3. We can also determine the common ratio. Since it's already in the geometric progression, the common ratio will be take the second term and divide it by the first term, and 6 divided by 3, that's 2. So that means the common ratio is going to be equals to 2. The n value is 7 because it's given up to the 7 terms that we need to find out the sum. So S7, which will be equals to, so first let's note down the formula. So we have the sum up to the n terms. This is given by a times. Now here clearly the r value is 2, which is greater than 1. So we will use the formula r raised to the power of n minus 1 divided by r minus 1. So we will have the first term, which is 3 multiplied to the common ratio 2 raised to the power of n, the n value 7, minus 1 divided by 2 minus 1, which will be equals to 3 times the 2 raised to the power of 7. So that's 128. 128 minus 1. So we have 3 times 127, which is 381. So this is going to be the sum up to the 7 terms of a given geometric progression. Let's move on to the second problem. So here we have another geometric progression. The first term being 1, second term is half, third term is 1/4, and the fourth term is 1/8. So let's find out. So here we will first specify the given first term. So our first term A, that's 1, the common ratio, our value. So that's, we'll consider the second term and divide it by the first term, which is 1. So our common ratio is half. And we have to find the sum to 10 terms, so n value is 10. Now this time the r value, clearly this is less than 1. So we're going to use the formula Sn equals to A times 1 minus r raised to the power of n divided by 1 minus r. So sum up to the 10 terms will be equals to the first term multiplied to 1 minus r. So r value is half raised to the power of 10 divided by 1 minus r. So that means 1 minus half, which will be equals to, so we have 1 minus 1 over 2 raised to the power of 10. So here we have 1 minus half, which is actually half. So this goes and multiplied with the numerator to give us 2 times 1 minus half raised to the power of 10. So we'll leave this value as it is. You can also use a calculator to obtain the value, but this is going to be the sum up to the 10 terms. Let's move on to the third problem. Problem number 3. So here we need to find the sum to the 7th term. So here we will first specify our given elements. The A value, which is the first term, is 2. The common ratio r is 6 divided by 2, which is 3, or 18 divided by 6, that's also 3. So this value is r is greater than 1. And we have our n value equals to 7. So the sum up to the 7 terms will be equals to first term multiplied to 3, the common ratio raised to the power of 7 minus 1 divided by r minus 1, which is 3 minus 1. So 3 minus 1 is 2. So the 2 and 2 from the numerator and the denominator cancels out. So we're left with 3 raised to the power of 7 minus 1 equals to. So let's find out the value. 3 raised to the power of 7. That is 2187 minus 1. So our final value will be 2186. So this is going to be the sum up to the 7 terms of the given geometric progression. Moving on to the fourth problem. So here we have our first term A, that's 1. The common ratio is 3 divided by 1, so that's 3, which has a value greater than 1. Then we have n equals to 8. So our sum up to 8 terms will be equals to the first term multiplied to the common ratio raised to the power of n minus 1 divided by 3 minus 1. So we have 1 half multiplied to 3 raised to the power of 8 minus 1, which will be equals to 3280. So this is going to be the sum up to the 8 terms. Moving on to the next problem. So here we have an alternating GP with a positive and negative values. So let's begin. So given the first term A value, so that's 1. The common ratio R will be negative half, which is the second term, divided by the first term. We have negative half. Then we have the n value. Since we have to find the sum to 9 terms, the n value will be 9. Now the sum to the 9 terms will be equals to the first term multiplied to 1 minus r value, which is negative half raised to the power of 9, whole divided by 1 minus r. So r value is negative half. So let's simplify it. So we'll get 1 minus, we have negative 1 raised to the power of 9. So we're pulling out the negative 1 value from negative half multiplied to 1 over 2 raised to the power of 9, whole divided by, so this will become 1 plus half. This is going to give us, so 1 plus half, so that's 3 over 2. This will go to the numerator to give us 2/3. 2/3 times 1, so negative 1 raised to the power of 9, so that's negative 1. So we have 1 plus, now 1 over 2 raised to the power of 9, so that's 512. So after further simplification, this is going to give us a value 171 divided by 256. So this is going to be the sum to the 9 terms of the given geometric progression. Moving on to the sixth problem. So here we have another GP. So let's find out. So here we have our first term equals to 4. The common ratio R will be 2 divided by 4, which will be equals to 1/2. So there's a term missing here. So actually this is not 4 2 half. So after 2 we'll have another term which is 1. So let me rewrite it. So this is going to ensure that the common ratio stays as half, because if we divide the third term by the second term, then we'll get half, and dividing the fourth term half by the third term 1, we're still going to get a common ratio of 1 half. Fine. The n value is equals to 10. Now finding out the sum to 10 terms, that will be a multiplied to 1 minus r. Since r is half, we this is less than 1, so that's why we're using the second formula for finding out the sum, which is 1 minus r, which is half, raised to the power of 10, whole divided by half, 1 minus half. So 1 minus half, that's half. Half will go to the numerator and multiply with 4 to get 8. So we have 8 multiplied to 1 minus 1 over. So 2 raised to the power of 10, that's 1024, which will be equals to 8 times 1023 divided by 1024, which will be equals to 1023 divided by 128. So this is going to be our sum to the 10 terms. Moving on to the 7th problem. Now we need to find out the sum to the n term. So let's begin. We will first specify the first term. So a value, that's since we already have an a here, so let me use uppercase A. So that will be equals to a squared minus b squared. Then our common ratio r, which will be equals to the second term a minus b divided by the first term a squared minus b squared. So this will be equals to a minus b divided by a squared minus b squared. So that's a minus b times a plus b. So a minus b gets cancelled out from the numerator and denominator. We have a common ratio 1 over a plus b. Now we do not know for sure. This will totally depend upon the value of a and b. This could be either greater than 1 or it could be less than 1. So we can use the more general formula, Sn equals to a times r raised to the power of n minus 1 divided by r minus 1. So our first term a, the first term a is a squared minus b squared times r. So r value is 1 over a plus b whole raised to the power of n minus 1 divided by, so r will be 1 over a plus b minus 1. So let's further simplify this. So we are going to get a squared minus b squared whole multiplied to 1 over a plus b raised to the power of n minus 1 divided by, we have 1 minus a minus b divided by a plus b. So that goes back into the numerator to give us a plus b times a squared minus b squared. So this is going to be the sum to the n terms of the given geometric progression. Let's go to the next problem. Problem number 8. We need to find the sum to n terms of the given geometric progression. Here we'll have to be a little bit careful while finding out the common ratio. First we'll have to rewrite the given progression. So we have x times x plus y, so that will becomes x squared plus xy. This is our first term. The second term will then become x raised to the power of 4 plus x squared y squared. The third term will then become x raised to the power of 6 plus x cubed y cubed, and this goes all the way up to n terms. Our task is to find the sum to n terms, so we will be summing up all the terms. So we have x squared plus xy, this is the first term, added to x raised to the power of 4 plus x squared y squared, this is the second term, and added to the third term, which is x raised to the power of 6 plus x cubed y cubed. This goes all the way up to n number of terms. Now we will write x squared, we will separate these into two sums. So our first term will be x squared followed by the first term of the second term, which is x raised to the power of 4. This will be combined with x raised to the power of 6 and so on up to n terms. Similarly, we will combine the second term of each of the terms. So we have xy plus x squared y squared added to x cubed y cubed, going all the way up to n terms. Fine. Now we will observe that immediately this is going to be one geometric progression and this is going to be another geometric progression. So let's call the first one as S1 and the second one as S2. So we have Sn, S1 plus S2. We'll come back to this in a moment. So let's tackle the first sum, S1. So our S1 is x squared plus x raised to the power of 4 plus x raised to the power of 6 all the way up to n term. So this is our geometric progression with the first term x squared and the common ratio r given by x raised to the power of 4, the second term divided by the first term, which is x squared. The common ratio is x squared. Therefore, Sn will be equals to the first term x squared multiplied to r raised to the power of n. So we have x squared raised to the power of n means x raised to the power of 2n minus 1 divided by x squared minus 1. So this is our S1 value. So this is the sum up to the n terms, and then we can find out S2 as well. So S2 is xy plus x squared y squared plus x cubed y cubed up to the n terms. So here the first term is xy and the common ratio is also xy. So our sum will be equals to the first term multiplied to the common ratio raised to the power of n. So we have xy raised to the power of n minus 1 divided by the common ratio xy minus 1. So now we can add the two sums to get this total sum Sn. So Sn will be then equals to S1, which is x squared multiplied to x raised to the power of 2n minus 1 divided by x squared minus 1 plus xy multiplied to xy raised to the power of n minus 1 whole divided by xy minus 1. So this is the sum up to the n terms. Let's move on to the next and the final problem. So we need to obtain the sum to 7 terms of the given geometric sequence. So let's begin. Our first term A will be 1 over 5 plus 2 over 5 squared, which is 25, plus 3 divided by 5 cubes, which is 125. So when we add them, this is going to give us a value 38 over 125. This is our first term. Now, to find out the common ratio, we'll rewrite the given sum. So here, let's take the sum Sn as 1 over 5. This is our first term plus 2 over 5 squared plus 3 over 5 cubed. So this is our first term plus in the second term, if we take 1 over 5 cube as the common factor, so then we will have within the parentheses 1 over 5 plus 2 over 5 squared plus 3 over 5 cube. Now for the third term, we're going to take 1 over 5 raised to the power of 6 as the common factor. So we just will get multiplied to 1 over 5 plus 2 over 5 squared plus 3 over 5 cube. This goes all the way up to the nth term. So clearly, we'll see that the common ratio r will be equals to 1 over 5 cube. So if we take the second term and divide it by the first term, so we're going to get 1 over 5 cube, which is 1 divided by 125. Or if we take a third term and divide it by the second term, we're still going to get a same common ratio of 1 over 125. So now that we have the common ratio r as well as the first term, we can obtain our sum to the 7 terms. So S7, which is the sum up to the 7 terms, this will be equals to the first term. So here our first term A is 38 over 125. So 38 divided by 125. Now here our value, so this is less than 1, we're going to use the formula 1 minus 1 over 125 whole raised to the power of 7 divided by 1 minus the common ratio, which is 125. So this is going to give us 38 divided by, so we have 124 multiplied to 1 minus 1 over 125 raised to the power of 7. And if we want to further simplify this, then 38 over 124 simplifies to 19 over 62 multiplied to 1 minus 1 divided by, so 125, so that's equivalent to 5 cube. And since we're raising it to the power of 7, so we have 5 raised to the power of 3 times 7, so that's going to give us 5 raised to the power of 21. So this is going to be the sum up to the 7 terms of the given geometric progression.